So when we finish up our trigonometry, we have to make sure that we are able to use our sine law, cosine law, our primary trig ratios, and all of our triangle properties in order to solve triangular problems. For example, word problems, diagram problems. But the biggest thing that you need to consider when you're solving triangle is which sides and or angles you're given and what you need to find out. And overall, you need to know what are you trying to figure out. So in our first example, we're going to determine the height of AC, which means we need to find out what is that side. Well, we're going to have to know a few other things. For example, here, the only thing in this triangle, well, two things that we know, is that this angle down here is 66 degrees. We know that this is a right angle triangle, which means we can obviously calculate what this angle is, but knowing three angles doesn't help us anything with side lengths. The only side length that we have is down here, which means we're going to have to know some more things down in this bottom triangle to help us calculate for this one. What we need to do is you're going to have to calculate what this angle is first, and then we're going to have to calculate what this side is before we can finally calculate what this side is. So when I calculate this one, it's pretty nice and basic. We have a triangle down here. No, it is not a 90-degree angle, even if you think it looks like it. We have two angles in it. That top angle in that bottom triangle would have to be 80 degrees. And now that we have a side and the angle across from it, we can use our sine law. So a sine of 80 over 50 would equal the sine of 45 over x. We can then do our cross multiplication. X multiplied by the sine of 80 equaling 50 multiplied by the sine of 45. And divide both sides by the sine of 80. That'll help us to calculate the one side in that triangle. $50 multiplied by the sine of 45. Dividing by the sine of 80. So that one side comes out 35.90075.215. Of course, at the same time, we're going to make sure we're just going to keep that in our calculator, because that's going to help us to calculate what our AC is. Now, the beautiful thing is, this is a right angle triangle, which means we can use our primary trig to help us calculate what the rest of it is. So in relation to our known angle in that triangle, our unknown is the opposite. The one thing that we've calculated is the adjacent, which means that we can use our tangent ratio. So the y over the x, and the x being 35.9. I've kept that in my calculator, which means I can now multiply both sides by 35.9. While keeping that in my calculator. I can get a nice and accurate answer so that I don't have any rounding issues. That'd have to be 80.6. And there we go. Now, in this case, yes, if you just did 35.9 multiplied by the tangent of 66, there shouldn't be any issues. But if you do round it incorrectly, it's going to become a problem. At the same time, keeping in mind, math is not specifically science. We can use an infinite amount of decimal places, whereas science has to use our significant figures. So be careful with those. A vertical flagpole is attached to the top of the building. A man stands 400 feet from the base of the building. From his viewpoint, the angle of elevation to the bottom of the flagpole is 60 degrees. To the top is 62.5. Determine the height of the flagpole. So we have the ground, and we have a nice building. We have some kind of flagpole at the top. A guy is standing 400 feet from the base of the building. He sees the flagpole. So I'll just draw a line from the base, even though, yes, we're talking about having height. If you have a height of person, we're going to deal with something. Actually, his height should be irrelevant. The angle to the bottom of the flagpole is 60 degrees. So that'd be a 60-degree angle. But it says to the top of that same flagpole is 62.5. Now, I'll just draw a horizontal, just see what his horizontal height would, or horizontal viewpoint would be. Now there's a whole bunch of different information that we have. Assuming, though, we can make a couple assumptions, and this one would probably be a very safe one. Most buildings are built at a 90-degree angle. This is essentially a grade 10 question. But I include it because you can still use your primary trig as long as you have a right angle triangle. We have an angle, we have the adjacent. Oh, we're going to calculate two opposite sides. So if we want to find out what the entire height here is, so calculate the height from here to the top of the flagpole, and we'd be taking the tangent of 62.5, equaling the opposite side, which I don't know. So we'll call that entire thing x over 400, which is the adjacent side. I can multiply both sides by 400. X is 400 multiplied by tan of 62.5. Here's my screen. And I get 768.4. In this case, feet. So that'll be from this bottom here to the top. But we just want to find out what is the height of just the flagpole. Sorry, I'll use a different character. Don't know what just that flagpole is, from there to there. But if we can find out what this is, we know that what the entire thing is, and we subtract off this part of it, well, we'd have what's left. Therefore, we can use the tangent of 60, which would equal, we'll call it y. Opposite y over 400. Multiplying both sides by the 400. 692.8 would be fine for this case. So therefore, we take our 680 or 768.4 and subtract our 692.8. We get 75.6 feet. So up to 75.6 foot flagpole. Notice how this for sure is not drawn to scale, which is fine. As long as you are able to draw your triangles and you know that it's making a triangle, you're fine. One final example. Colleen and Juan are the two bestest friends. They set up an experiment to observe air pressure and wind speed in Juan's field. Juan releases a 200-gram balloon and walks away. After 15 seconds, Colleen observes the balloon at an angle of elevation of 7 degrees. Juan observes a balloon at an angle of elevation of 82 degrees. If the friends are 250 meters apart, determine how high is the balloon to the nearest tenth of a meter. Now I have a note about speed, but we'll talk about that after. So, balloon is going up in the air. Make it nice and fancy. For reading this question, the fact that it's a 200-gram balloon really is irrelevant. We don't even need to know that bit of information. What we do need to know is that Colleen is observing it at an angle of elevation of 7 degrees. So she's observing at a 7-degree angle. Whereas Juan is observing it at an angle of elevation of 82 degrees. The only other bit of information that we have is that they are 250 meters apart. We need to find out how high is the balloon. What is the height? So we're going to use some information. For example, how to calculate this one. Well, we're going to have to calculate what this angle is. We'd have to take 180, subtract the 82. It goes 98 degrees. To go further, we'd also have to calculate what this top angle is, which would be 180, subtracting the 98, subtracting the 7. Doing my math correct, should be 75. Good. Just double checking. Can't be too sure sometimes. Okay. Now, in this triangle, the only thing that we can really do is either calculate this long side here or calculate this side. Either way, it's going to work. If I calculate what this is, I'm going to use the sine of 98 over the unknown would equal the sine of 75 over 250. Do our cross multiplication, question mark, multiplied by the sine of 75 will be 250 multiplied by the sine of 98, divide by our sine of 75. sine 98 divided by sine of 75. I got 256.3. Our unit is meters. And then I can use that long side. Obviously, I have to make a small assumption that the balloon is actually going straight up. But now we can use our primary trig. This is our opposite side. This is the hypotenuse, which means we can use the sine ratio. So the sine of 7 would equal what our unknown height is, divided by this 256.3, so on and so forth. Multiply both sides by the 256.3. Multiply by sine of 7. Height I get is 31.23514, so on and so forth. Now the only reason I'm writing out a whole bunch more on this is just because we could have calculated it another way. We could have calculated this side. So if I calculated that side, let's see, what color can I look for? I'll call it green question mark. I could have used sine of 7 over question mark equals our sine of 75 over 250. Still, after all the calculations, obviously I would expect that you would show your work to 150 multiplied by the sine of 7 divided by the sine of 75. I get 31.542, so on and so forth. And then I can use that side and my 82 to find out my height. So the sine of 82 would equal the height divided by 31.542. Forward 2 multiplied by the sine of 82. Obviously, that's a rounded value. And I get the exact same value. I still get 31.23514 unit meters. So question is asking to nearest tenth. So 31.2 meters. But are we finished? No. Because it doesn't say that Juan is walking towards Colleen. He could have been walking away, which means we have another triangle to create. This one, I know for sure, is not going to be drawn to scale. But it still sets us up for a lot of our information. Colleen is 7 degrees away. Our balloon is up there. Juan sees an angle of elevation of 82 degrees. The entire distance that they are away apart from each other, 250 meters, which means we're going to have to do a little bit more information. For example, we're going to have to calculate what this entire side or angle is. So we take our 180, subtract 7, subtract 82. Yeah, 91. So the sine of 91 over 250 would equal, well, we need to find out still the height here. There's no direct calculation that we can do to calculate what the height is, which means we're going to have to calculate either what this is or what that is in order to use the right triangle to find out our information. It doesn't matter which one. I'll use a 7 just the same as over here. It didn't matter which triangle we solved. It all works out. So do a cross multiplication. So question mark multiplied by the sine of 91 would equal 250 multiplied by the sine of 7 divided by the sine of 91. And our unknown value will be 250 multiplied by the sine of 7 over the sine of 91. 50 sine of 7 divided by sine of 91. 30.47, so 1/4. So that would be that side, which means that I'm going to have to use my 82 with my primary trig. So my primary sine ratio, because it's the opposite and we have calculated what the hypotenuse is. So our height, 30.47, multiplied by both sides by the 30.47. So I'm just going to add an extra division on this just to make completely obvious. The height here will be 30.47, obviously keeping all my decimal values in my calculator, multiplied by the sine of 82. Height that I get to the nearest tenth, as the question says, is 30.2 meters. And you'll notice that the two values are different because there's two possibilities. Either one could be walking towards Colleen or one could be walking away from Colleen. Obviously, these would be the two extremes. If one was walking, say, towards us or into the screen even further, the calculations would be slightly different. We could do it, but we'd have to know exactly at what angle he's actually walking. This would be the maximum height that the balloon would be. This would therefore be the minimum height that he would be reaching. Now I just add in one special part because I do enjoy my physics. To calculate speed, it's distance divided by time. So our questions are done here. But if we want to calculate what speed that the balloon is actually traveling, we just have to take the distance that it travels and divide it by the time. Now, it says that is observed after 15 seconds. So we're going to just be dividing it by 15. So our 31.2 divided by 15 is 2.08 meters per second. Per second. I always seem to do that with my S's. I don't know why. And this speed will be 30.2 divided by 15. Comes out as 2.01 meters per second. And there we have it. So you can go have fun.